Everyone. So in this opportunity, I would like to present the final project of data miner course of mine. So first of all, let me introduce myself first. So my name is Yusron Hanan, and I would like to present all of the final project of data mining for this session. So first of all, we have right here we have four parts. I divided into four parts for this presentation. First is background and goal, and second is exploration and data preparation, and third is build the classification model by using auto machine learning, and fourth is association analysis methods by using FP growth. So first, for the background and goals, in this study, we will use the given dataset, so which is data mining cup 2019 dataset. So in terms to fulfill the requirement for the final project, then we will do the two experiments, which our first one is classification and the second one is association analysis methods to generate the useful rules. So the goal itself is for the classification is experiencing learning by the classifier is chosen automatically by the automation learning based on the given dataset, based on the data mining cup 2019, and the automation learning will find the best classifier based on the given dataset, and the label class in the given dataset is a fraud column. We will jump into that later. And the second one is the goal for the association analysis methods is experiencing to find the frequent pattern in the data. So it will produce the useful rules. So we in this final project, I will do two things with the given dataset. So next is data description. So this is the data from the data mining cup 2019. So first we have like 10 of it. So first one is the trust level, total scans time in seconds, grand total, line item fights, scans without registration, quantity modification, scan line items per second, value per second, line item fights per position, and the last is fraud. So the data it consists of 10 features with the label class is fraud. So with 0, then it's a not fraud, and 1 is a fraud. For the value range, it's different for each features, but most of it is just the numerical types. And for the description, I will mention maybe some of it. For the grand total is a grand total of product scan, and like quantity modification is like a number of modified quantities for one of the scanned products, and for the values per second, average total value of scanned product per second, and for the fraud itself, as I mentioned before, is a classification as fraud 1 and not fraud is 0. The next is exploration and data preparation. First one, basically I also do the code, but I just make it into the slide, so I will just focus on it, and maybe if we need to jump onto the code, then I will jump to the code. Then first one is what we do is import the library. So we import like the NumPy, matplotlib, pandas, seaborn, and sklearn. So and for example, like matplotlib is for to visualize the data, and seaborn also for the visualize the data, and for the pandas is for the manipulation to the data frame and to the read the given data set, and for the sklearn is to do the build process and etc. for the scale of the data. And then next is read the given data set. First we read the train data set, and we see right here, if you can see, the data is not good enough. I mean, it consists of one column with a lot of strings, and this one or two, but we can see the patterns. It looks like it's basically the data for each features is divided by the line, the line string. I don't know how to call it. And then the third one, we split it into, so we can get the right model. So we split it this one into this one. So now we can get the data and it's readable, and it will be easier to be manipulated. And then next is check duplicate and missing value. So the duplicated row here, we can see there is no duplicated row, but the missing values too, so which is good. So the data, it means good. And then next is we visualize the data. So we see the very data of each column, so we see the distribution about the data. So maybe if we found from this data, I didn't see any like only a single distribution, even though, yeah, you can see it's basically the decimal. So we don't need to drop any column. And the next is and also the variations of data is quite variative, is quite distributed. But for this one, it seems like it has different ratio significantly with the other values. And the next is see the relation of each column to class label, which is fraud column. So in this one, you can see the trust level, the relation, and this one, it's consists of like a lot of decimal, I think. This one, the grand total 2, this one, and the next is scan without registration, quantity modification, scan item per second, value per second. We can see the distribution is quite good, but you can see a big picture that the fraud with the number 0 is a huge number. It significantly have a different ratio. So yeah, the fraud with 0 number have more portion rather than the fraud is 1. And the next is we want to see the outliers for each feature. So we do the box plot here, and as you can see, we can see some outliers here. It's for the second line item value per second, and line item void position per position. So we need to remove that because it will be bad to our data. So we remove it, the outliers, by using 1.5 IQA. And then we got here, it's already removed the outliers. And the next is we set the train and test dataset. So as you can see right here, we already got the data, we already removed the outliers and etc. And now we set the X train, X test, Y train, and Y test. This one, the X train and Y train. Y train consists of the fraud column only, but the X train only all of the features except the fraud column. So with the X test 2, with Y test 2, but the different Y test is for the X test is taken from the test.csv given dataset, and we need to produce it too, like the previous one. We need to split it with the line column. And for the read CSV, we get it from the DMC-2019-realclass.csv. Okay, and then we got our train and test dataset. Now we scale the data. So we use the standard scaler. So the reason is because it will remove the mean and scales each feature to unit variance. So it will, because of the differences, yeah, the number, the range of the data is different, so we need to scale it. And it is performed feature wise in an independent way. And also basically standard scaler is sensitive to the outliers, but it will be fine because we already removed the outliers before. And the next is we build the classification model by using auto machine learning. So we jump into that. So we use teapot here to do the auto machine learning, which is to find the best classifier. So the reason why we use teapot is because of it can be used in Python, in Jupyter Notebook, and myself already uh, familiar with the type of the scikit-learn, and the teapot itself, the type, how to use it is pretty similar with the scikit-learn. So it helps me a lot to understand how the teapot works. So in this part, as you can see, the teapot, yeah, is a teapot classifier icon here, and with the parameter generation is 5 and population size is 50. So the reason why I choose these parameters is because of the data is basically is not that huge, so we don't need to use a high number here. And then for the verbosity, it hasn't it just shows the info here, so it's nothing to do with the classifier process. And for the random state, yeah, it's just if you run the the data again, it will produce the same random, so it will help in the process of the memory usage. And then it's yeah, teapot find the best classifier, and then it's generate the CV score. And then we get here, as you can see, I want to see the chosen best classifier with also with the parameters. It shows a multi-layer perception classifier with the parameters that you can see the image here, and it automatically produced by the teapot before from the given dataset. So yeah, the dataset analyzed by the teapot, and the teapot will find the best classifier. And then yeah, and the next is, yeah, we also able to produce the code of the classifier for the multi-layer perception classifier. And the next is the evaluation we can get here is 98%, which is pretty good. And for the F-score itself, it's actually good. As you can see, for the detect the fraud 0 is 99%. For the F1 score, also the recall and precision for the detect in the fraud equal to 1, it 84% for the F1 score, and for the recall 89% and 80% for the recall and precision respectively. So it shows it's it's produced a good one, a good number, the high accuracy and also the high F1 score, recall and precision, which is how machine learning can be used. And yeah, we can see here for the conclusion for the classification is by using automation learning, it shows a good performance, a high number, and it shows that we as human can set automatically the machine to apply which machine learning that should be applied to real world problems. And then for future improvement, maybe by provide more dataset for fraud. Column is 1 can improve the accuracy, and F score for the in detect of the fraud is 1. Okay, and then next is association analysis methods by using FP growth. So this is the second experiment that I'm doing. So first one is import the library of the FP growth. So and also I import the association rules, also the copy. So because I need to copy the previous dataset before, so it will not changes the previous one. And then set the dataset first, and the second is set the dataset. So here I got the data from the train and from the test dataset before, so I didn't need to produce again, and I put it in this variable. They have train temporary and they have test time temporary, and I concatenate it, so I will get all of those train and test dataset. So this association data frame. And the next is third is a change fraud column data. So change the 0 into no, 1 is yes. Why? The reason is because in discretize the data, it will detect the the fraud column has only one in the one discrete, so it bats. So that's why I need to change it into no and yes. And the next is discretize the data, because of association rules will be more effective if we only have a few columns. Thus we discretize the data, and the discretization or binding range is based on the quartile of each data, which we consider a good range of each data, since we do not want to exploit the data dimensionality even more when doing one-hot encoding. So yeah, we already split into discretize it. And then next is one-hot encoding data. We split for each discretized data into one thing right here. And then so to make the category, the reason why we one-hot encoding the data, because to make the categorical data is readable by the FP crowd algorithm, we do one-hot encoding for all columns as mentioned before. But for column, the reason is to convert no and yes, because it allows the one-hot encoding process success, as like here. So we got here. If I didn't change it into no or yes, it will be in the single column. And the next is we apply association rules. So the parameter that we use is for the minimum support is 0.1 and matrix is confidence, and for the minimum matrix is threshold. The reason why we choose that specific number is when I try to put it in under 1, it will produce a lot of association rules, which is significantly more than it. I think it's double of it and triple of it. And when I set it 1, it's exactly got a good one, I think. So yeah, that's the reason why I choose these parameters. And then we do the reason why we use FP group for this association analysis method is because it's better than a priori. It produces less candidate items, and in the process it does not scan the item set database over and over again. So yeah, it's more faster rather than the a priori, and it's better than a priori. And then we already generate rules, but we need to split it into the fraud is yes and fraud is not. But the result shows that only produced for the rules is not, which is rules is 0. The fraud is 0. The reason, I think it seems since the given dataset train and test dataset not have a proper ratio for fraud is 1 and fraud is 0, because if I see the data, the fraud is 1, it's only 4.76% over the fraud is 0, which is significantly the number of it is significantly different. But that's okay, so we can get the rules for the fraud is not. So the fraud is 0 interpretation from this one is the number of voided scans is between 0 to 11, and average number of item voids per total number of all scan and not cancelled product is between 0.692 to 11, and number of modified quantities for one of the scan products is between 0 to 4, and average number of scan products per second is between 0 to 0.00868, and total time in seconds between the first and last product scan is between 1375 to 1831, and the last one is customer's individual trust level is between 2 to 6. So we can get maybe to get the rules of the fraud. Maybe we can show that, okay, if it's fraud is 0, it means that with this interpretation, with this range, with these rules, that means it's not. but for the other, it's fraud, but we cannot say it is fraud because we cannot produce any rules here, but we can maybe suspect them. Okay, that's all for me. We can get the yeah, I already experiencing how to find the best classifier by using automation learning. I also get and also generate the rules based on the library column, which is it's pretty good chance for me to learn. And that's all for me for the final project of this data mining course. And if you watch until the end, thank you very much and see ya.